Rising transportation costs and increasingly restrictive environmental regulations for cuttings disposal have led operators to seek higher quality treatment of oil and synthetic-based cuttings. Halliburton's Thermomechanical Cuttings Cleaner, or TCC, effectively removes oil from contaminated cuttings, which minimizes waste transportation and environmental impact. The TCC not only minimizes waste requiring transport, but recovers valuable base oil to be reused in drilling fluids, reducing overall fluid costs. Halliburton Baroid engineers custom design each waste management system. Careful planning of the solution through our process ensures maximum efficiency and meeting HSE standards. When selected as part of the solution, the Halliburton TCC has distinct advantages: high processing capacity, and the most flexible design in the industry, allowing it to be configured to process waste in both onshore and offshore environments. The system uses thermal phase separation to remove oil and water from cuttings. The 5 modules consist of feed unit, drive module, process mill, condenser module, and rehydration module. Oil-based cuttings are transferred to the feed unit by pneumatic transfer system and enter the TCC. Twin-cylinder piston pumps deliver a constant flow of feed to the process mill, regulated automatically by a control system to maintain the desired temperature in the process mill. The process mill is the heart of the TCC process, generating friction heat that evaporates water and oils present in the cuttings. Intense agitation of the rotor causes motor energy to be transferred as heat to the cuttings. Water and oil in the material are flash evaporated. The load on the drive end is determined by the thickness of the cuttings and is automatically controlled by the process mill discharge valve, allowing the discharge of solid cuttings. Gases are moved out of the process mill and are directed to the gas outlet vapor line. Approximately 90% of the solids are discharged directly from the process mill discharge valve. Cuttings with less than 1% oil on cuttings are conveyed through cooling conveyors to reduce the temperature to 212 degrees Fahrenheit or 100 Celsius. Cuttings enter the rehydration module and are rehydrated using the recovered water from the TCC process. This eliminates dust contamination in the processing plant and makes cuttings easier to transport. The vapors from the process mill move to the condenser module, where a 4-stage condensing process takes place. Oil scrubber, oil condenser, steam condenser, and oil and water separator. In the oil scrubber, the remaining ultrafine solids particles are removed from the vapor stream and are recovered into a sludge, which is transferred back to the feed unit for further processing or discharged. About 5 to 15% of the oil in the vapor is condensed in the oil scrubber. The remaining oil vapor is condensed in the oil condenser. As the oil flows downward, it cools the flowing vapor, which leads to condensation of oil. The cooling is controlled to achieve a final vapor temperature of 221 to 230 degrees Fahrenheit, or 105 to 110 Celsius, to avoid condensation of water. A level switch opens for discharge of oil. Water vapor moves into the steam condenser, which uses the same method as the oil condenser. The temperature is lowered so that all vapor condenses into water. Because there is some carryover of light oil fractions from the oil condenser to the steam condenser, an oil-water separator is fitted to the steam condenser and has 2 outlets. One to the recovered water pump and one to the recovered oil pump. As an added environmental advantage, the recovered oil can be used to fuel the TCC, increasing recycling on the rig and further reducing waste. A Halliburton engineer monitors and controls the TCC process, either by computer screen in the TCC control room or remotely, an excellent benefit for offshore operations. This can take place at a remote operations center or by anyone with access to data for the rig.